Catching clouds, the magic of desert fog nets. Imagine walking through the desert at dawn. A curtain of mist drifts like a ghost through the dunes. Fog in one of the driest places on Earth? It's not a meteorological fluke, it's an invisible treasure. And thanks to a clever bit of science, humans have learned how to catch it. Welcome to the world of desert fog nets, where science meets survival, and the desert itself lends a helping hand. A thirsty land. Deserts are famous for what they don't have: water. The Atacama Desert in South America is so dry that some parts haven't seen a drop of rain in centuries. Yet on the outskirts of Lima, Peru, nearly 2 million people still try to make a living here. 1 in 5 families has no access to clean drinking water. Instead, they rely on expensive water trucks that rumble through the sand, delivering water that's often late, costly, and unreliable. And those trucks? They come with a heavy carbon footprint, puffing out CO2 as they go. This desperate need for water inspired a revolutionary idea: fog catching. Enter the Creating Water Foundation, a Dutch nonprofit with a simple, brilliant plan. If the desert air won't rain down water, maybe it can hand it over gently through fog. Using this logic, they've set up 60 fog nets in Peru, bringing 10,000 liters of clean water to nearly 500 families. It's one of the most quietly beautiful technologies on Earth, because it doesn't fight the desert, it listens to it. The net that drinks the sky. Picture a volleyball net stretched between 2 poles on a hilltop. Now imagine the net drinking. That's essentially what a fog net does. Each net is made from a fine plastic mesh, usually polypropylene or polyethylene, that hangs like a giant spiderweb in the wind. When moist air drifts through, tiny droplets of water cling to the fibers. As more droplets gather, they merge and grow heavier, until drip. They slide down the mesh, into a gutter, through a pipe, and into a collection tank at the bottom of the hill. It's a marvel of simplicity. No pumps, no power, no pollution. The only forces at work are wind, fog, and gravity. Nature's oldest team. How the magic happens. Here's how fog farming works step by step. 1. Find the fog. The nets are set up on hilltops or coastal ridges, where fog often rolls in from the sea. 2. Catch it. Wind blows the fog through the fine mesh where droplets stick to the threads. 3. Merge it. As more fog passes, droplets combine into larger drops. 4. Guide it. Gravity helps the water run down into gutters and pipes. 5. Store it. The clean water collects in tanks for drinking, cooking, or even watering small gardens. In places like Lima's dry hills, one well-designed fog net can capture up to 15 liters of water per square meter of mesh per day under the right conditions. Multiply that by dozens of nets, and you can see how these ghostly curtains are transforming entire communities. The physics of fog farming. So what's the science behind the magic? It all comes down to a few physical principles. Condensation. When the warm, moist air in fog touches the cooler surface of the mesh, water vapor turns into liquid droplets. Surface tension. The droplets cling to the fibers, growing larger as more moisture joins in. Gravity. When droplets become heavy enough, they roll downward, gathering into streams that can be collected. Material design. The plastic mesh's texture and spacing help maximize water capture while allowing air to flow freely. This process uses no electricity, no mechanical pumps, and no filters except the mesh itself. It's science distilled to its purest form: simple, renewable, and astonishingly effective. And in case you're wondering where the inspiration came from, credit goes to a humble desert insect, the Namib Desert beetle. This beetle survives one of the world's harshest climates by collecting water from fog on its back. Tiny bumps on its shell help droplets form and roll straight into its mouth. Engineers took that natural design and applied it to fog nets, proving once again that sometimes the best inventors have 6 legs and wings. Why it matters. Before the fog nets, families in Peru's desert communities often spent hours hauling or buying water that cost more per liter than in the city. Today, clean water literally flows from the air. It's used not only for drinking, but also for fog farms that grow vegetables and herbs in once barren soil. And the difference doesn't stop at the tap. Unlike the noisy, fuel-hungry water trucks, fog nets produce water with 0 carbon emissions. They operate entirely on the forces of nature, making them one of the most eco-friendly technologies in the world. The cost? A fraction of what it takes to truck in water, and maintenance is minimal, just a periodic cleaning of the mesh. One local woman in Lima said, "Before, I waited for the water truck. Now I just wait for the morning fog. You can't buy poetry like that, it floats in the air." From fog to future. What started in Peru is spreading across the globe. Fog nets now harvest water in Chile, Morocco, Namibia, and even parts of California, where they help farmers and communities facing drought. Scientists are experimenting with hydrophobic coatings, special materials that help droplets slide off faster, and optimized angles that boost water capture by 50% or more. The vision: imagine entire desert villages powered, not by wells or pipelines, but by clouds. Some researchers even dream of future fog catching skyscrapers. Buildings wrapped in mist-harvesting fabric, turning morning fog into fountains. But the real magic isn't in the materials or the physics. It's in the idea that the planet gives us everything we need if we learn to look carefully. The desert, once seen as empty, turns out to be full of potential. A drop of humor and hope. Of course, nature still has its moods. When the fog forgets to show up, locals joke, "We pray for fog, not rain." To an outsider, these fog nets might look like giant laundry lines. But to those who depend on them, they're miracles in mesh. So the next time you see fog drifting over a hill, don't just call it mist. It's a moving ocean in the sky. Somewhere out there, someone is catching it, drop by precious drop.
It's time to study new words in context. 1. Dune. Definition. A dune is a hill or ridge of sand formed by the wind. Usually found in deserts or near beaches. Over time, wind pushes sand grains into gentle waves, creating dunes that move slowly across the landscape. Example: the travelers climbed the tall dune and watched the sun set over the golden desert. 2. Meteorological fluke. Definition. A meteorological fluke means an unusual or unexpected weather event that doesn't normally happen in a certain place or season. Meteorological relates to weather and climate, while fluke means a rare or lucky occurrence. Example: snow in the middle of the desert would be a meteorological fluke that surprises even experienced scientists. 3. Rumble. Definition. To rumble means to make a deep, continuous sound, often like thunder or an engine. It can also describe the low vibration made by vehicles moving or storms approaching. Example: water trucks rumbled through the dry streets, shaking the ground as they delivered their heavy loads. 4. Hydrophobic. Definition. Hydrophobic describes something that repels water instead of absorbing it. The word comes from Greek roots, hydro meaning water, and phobos meaning fear, so it literally means water-fearing. Scientists use hydrophobic materials to help water roll off surfaces quickly. Example: engineers designed the fog nets with hydrophobic coatings so that droplets would slide off faster into the collection pipes. 5. Skyscraper. Definition. A skyscraper is a very tall building, often found in cities, that seems to scrape the sky because of its great height. Skyscrapers are built with steel and glass frames to support many floors. Used for offices or apartments. Example: from the top of the skyscraper, the city looked like a glittering maze of lights stretching to the horizon.
Comprehension questions. 1. What is a desert fog net, and what does it do? Answer. A desert fog net is a large mesh screen that collects water droplets from fog. As moist air passes through, the net traps tiny droplets that merge and drip into collection tanks, providing clean water in dry regions. 2. Where is one of the driest places on Earth mentioned in the article? Answer. The Atacama Desert in South America, particularly the coastal region near Lima, Peru, is described as one of the driest places on Earth. 3. What problem do many families in Lima, Peru face? Answer. Nearly 2 million people in Lima's desert outskirts lack access to safe drinking water. They rely on expensive, unreliable water trucks that also produce high carbon emissions. 4. Who created the Fog Net project in Peru? And how many families benefit from it? Answer. The Dutch nonprofit Creating Water Foundation started the project. Their 60 fog nets now supply about 500 families with roughly 10,000 liters of clean water. 5. How does a fog net work? Step by step. Answer. 1. Fog flows through a fine mesh. 2. Water droplets stick to the fibers. 3. Droplets grow larger and heavier. 4. Gravity pulls them downward. 5. The water drips into gutters and flows into storage tanks. 6. What materials are fog nets usually made from, and why? Answer. They're typically made from polypropylene or polyethylene, which are lightweight, durable plastics that trap moisture effectively while allowing air to flow through. 7. Why is a fog net called a net that drinks the sky? Answer. Because it captures water directly from the air, turning invisible fog into drinkable water, almost as if it's sipping from the clouds. 8. What natural creature inspired the design of fog nets? Answer. The Namib Desert beetle, which collects water from fog on its back, using tiny bumps that guide droplets to its mouth. 9. What scientific principles explain how fog nets work? Answer. They use condensation, turning vapor into liquid, surface tension, droplets sticking to fibers, and gravity, pulling the water downward into tanks. 10. How do fog nets help the environment compared to traditional water delivery? Answer. Fog nets produce water with zero carbon emissions. Unlike water trucks that burn fuel, they are renewable, low cost, and rely only on natural forces like wind and fog. 11. What humorous saying do locals have about the fog nets? Answer. Locals joke, "We pray for fog, not rain, since fog not rain brings them water." 12. What are some additional uses of fog-collected water besides drinking? Answer. It's used for cooking, irrigation, and fog farming, growing vegetables and herbs in once barren areas. 13. In which other parts of the world are fog nets being used? Answer. They're also used in Chile, Morocco, Namibia, and California, where they help communities facing drought. 14. What are scientists doing to improve fog net technology? Answer. They're developing hydrophobic coatings to make droplets slide off faster, and optimizing the net angles to increase water collection efficiency by 50% or more. 15. What larger message does the article convey about humans and nature? Answer. It shows that humans can live in harmony with nature by learning from it, using creativity and science to find sustainable solutions, even in the harshest environments.